Okay, so we are continuing from where we stopped last week. When we met last week, we saw how to create data structures. In this particular case, we saw how to create lists, tuples, sets, and dictionaries. The other thing we did was how to access the items you have added in your lists, in your tuple, in your dictionary, and also in your set. We also saw how to find the size or the length of your data structure, because as you are aware, these things contain a certain amount of data. So basically you want to find out how much data you have added. So this morning we are going to proceed with some of these common activities or tasks which you can carry out with respect to these data structures. And also, I want to remind you that what we are actually looking at is not conclusive. It's not everything you can do with these structures. Basically, the lecture is arranged in such a way that we look at these things together while highlighting the differences between these different data structures, because they are not the same. They behave differently, and they've got different properties, and they handle data differently. So there is always this whole bit of me highlighting how this bit is different from the other one, what you can do with this structure, what you can do with that structure. So basically, what you're going to look at is not everything, but I would like to point out that for each data structure, there is actually a specialized lecture which is there. So once you are done with this, you can go and specifically look at the lecture for lists, you can look at the lecture for tuples, you can look at the lecture for sets, you can go and look at the lecture for dictionaries. So basically, after this, this thing should make it easy for you to go and look at those 4 lectures, which I think in total there might be 4 to 5 hours. But these 4 to 5 hours, we are compressing it into 2 hours because we don't have enough slots for us to look at just these things. So what you're going to start doing this morning is, how do you change the value which you have added into a data structure? Because you might have added value, but then you might want to change it. So we're going to start with lists. So for you to change the value which you have added to a list, you need to know the name of the list. You need to know the position where this particular value you want to change is, and you need to have a value which you're going to use to change. So we have already created a list, and as you can see, we have created it already. I've run this code quickly. If you come here, you can see it says variables there. If I press there, you're going to see a list of variables I've created, and they're different types. So basically, this workspace here gives you a list of what kind of variables you have created, what are their types, and how many items these variables have. As you can see, for what we are interested in, which is fruits here, fruit is a list, and it has got 7 items. And you can see there's this other box which comes down here, which tries to show you what items I have in that particular thing. So basically, these things we have created have got values in them. So the good thing about a data structure is it can hold several items or several objects. So if I click back, so for our fruits, we print our list fruits, and we do that by giving the name of our list to the function print, and this is basically what we have. Now we want to print out the last item in this particular list, which is orange, what you have there. Now the last item in a list can always be accessed. It doesn't matter how big a list is. You can always access the last item using the index -1 to show the last item. So if I print out the last item, so I to the print function, I give the name of the list, which is fruits, then the position of the last item, which is basically what I have here, -1. If I do that, you will see that I have access to this last item, which is orange. Now what I want to do is that I want to change this last item, the value of the last item. I want to change it to something else. I want to change it to blueberries. So for me to make this change, I will start out with the name of the list, which is fruits, then followed by, in square brackets, the index of the position I want to change. So I'm saying I want to change the last item from what it is, which is orange. I want to change it to blueberries. Then equal sign, then I assign the value I want to replace the orange with, which in this case is blueberries. So we do that. Okay, it runs. Then if I make a printout of my updated list, now instead of orange at the end here, you have blueberries. So you can see the same list. In the first instance, it was orange. Last item was orange. Now you've got blueberries. So for you to change the value of an item, you need to tell us, you need to tell Python the name of the lists, then in square brackets, the position of the item where you want to change, then after that, an equal sign followed by the value you want to place at that particular location. Is that clear? Next, we are going to move on to a tuple. Now, tuples are lists also. The difference between a tuple and a list is that in a list, you can do what you have done. You can change an item, the value of an item in a list. But in a tuple, you cannot do that. In a tuple, you're not allowed to change the value of items. Once you create a tuple, then you're not allowed to change anything. So in this particular case, we have got a tuple called prime numbers. So here, I've got prime numbers, and this is basically what you have. Then I want to access the fifth item. So in this particular case, the fifth item is here, 1, 2, 3, 4, 5. So you can see the prime number 5 is occurring twice. It's fine. An item can occur multiple times in a tuple. The only difference is you can't change things. So if I want to change that 5 and say I want to add another prime number instead of the 5, for example, in this particular case, I access the fifth item, which is a 5. Then I want to change the value of the fifth item in a tuple to another prime number. In this particular case, I want to change it to 23. Okay, so I start out, I try to do this. I know it's not going to work. I try to do this. I start with the name of the tuple, then the position of the item I want to change, then I assign that position a new value. I try to assign the position a new value, which is 23. If I run this process is going to fail. So in this particular case, you see that, yes?
I'm trying to join, maybe you can.
Oh, okay. All right. So in this particular case here, you can see that Python brings out the red pen and tells you that this operation you're trying to do is not possible. And what's the problem? In this particular case, the Python says this is a type error. Tuple object does not support item assignment. Basically, this is a fancy way of saying that when you have a tuple, you are not allowed to change the value of the items in the tuple. So this is one of the differences. Okay, next we move on to a set. Now, we have created a set called static. So if you print the set static there, that's what you have. Now the issue with a set is that in a set, the first thing you have to remember about a set is that an item can only occur once. So you can't have the situation where we have, like in the tuple where 5 was appearing twice, or like in the fruit where orange was appearing twice. With a set, an item is only allowed to appear once. The other thing about a set is that the idea of position doesn't exist. You can't say first item, second item, let me access the first item, let me access the second item, let me access the last item. That does not exist. Since position doesn't exist, it's not possible for you to actually access an item. If you can't access an item, it means that you can't modify anything. Because for you to access an item, for you to modify an item, you must be able to first know the position of the item you want to access, then give it a new value. But in this particular case, it's not going to be possible to do that, as I'm going to show. So the first thing I've done here is, of course, I've printed out this set, which we have here, a set of static countries. Then I try to print out the first item. So with this exercise, I'm trying to show that the idea of position in a set doesn't exist. You can see the first item here in this particular set is Mauritius. But can we access that? So if I say print Sadiq, then in square brackets, I give the position of, I try to give the position of the first item. If I try to do this operation fails. And there's a type error which says that set objects are not subscribable. Basically, you can't, there's no index. So if there is no index, then you can't change position. It doesn't mean that you can't remove things from a set, or you can't add things to a set. You can add stuff to a set, you can remove things from a set. The only thing you can't do is change the value of an existing item. You can't do that. Is that clear? Is that clear?
Yes.
So for a set and a tuple, for different reasons, you can't change the value of an item in a tuple. Next, we come to a dictionary. Now for a dictionary, you can change things. And of course, dictionaries work differently. We have got a dictionary called capitals. So I'm going to print out this dictionary capitals here. So as you can see, for those, so here is the key Zambia, and the corresponding value is Lusaka there. So basically, this is how dictionaries operate. The items in dictionaries come in form of key value pairs, where the first item before the colon, that is a key. Then after the colon, after the colon, you have a value. Then these key value pairs are separated by commas. So if you have a quick look, you see Angola, which is a key, Luanda is a value, Namibia key, Windhoek is a value, Botswana key, Gaborone is a value, and stuff like that. These are basically capitals in our southern African region. Now I want to access the capital city of Zambia. So for me to access the capital city of Zambia, with a dictionary, you don't use indices because indices are values. But with a dictionary, you use the key associated with that particular value. So if I want to access Lusaka, after the name of the dictionary, which is capitals here in square brackets, I put in the name of the key, in this particular case, which is Zambia. So I say print out, so capitals, then in square brackets, I put in the name of the key, which is Zambia. When I do that, I'm able to access the value associated with Zambia, which is Lusaka. Using this same key, I can change the value associated with the key Zambia. From Lusaka, I can change it to $. So for me to do that, I will start out with capitals, then square brackets, then the key, which tells me what I want to access, which is Zambia. Then I want to change the value associated with Zambia from Lusaka to $. I do that. Then if I run this, that happens. Then now if I print out the key associated with Zambia, now it has changed to $. And if I print out the whole list, you'll be able to see that now Zambia, the key Zambia, is now associated with the value $. So basically, this is how you change the values in a dictionary. So this is about you changing. So basically, that's how we make changes there. Any questions? So you can make changes with the lists, you can make changes with the dictionary, but you can't make changes with the tuple, you can't make changes with the set. So there is that bit there. How do we add items to a data structure? The first thing I'm going to look at is how you add items to a list. There are 3 ways of doing this. You can add a single item through a process called appending. You can also add another single item through a process called inserting. Then you can also extend the lists. So when you append, you're basically adding an item at the end of the list. When you insert, you need to specify at what location you want to insert this particular value. So the location, the index, you need to specify. Then the item you're going to insert is going to be inserted just before this particular index. It's like you trying to insert someone in the line. So at this particular location, you open up, then you insert there. Then when you extend, basically when you extend, you're simply adding a list at the end of another list. So it's basically extension is done at the end. You extend at the end, but you can add multiple items, as we are going to see very, very soon. So here is our list of fruits. So this is our updated list: mango, guava, orange, grape, lemon, cucumber, and blueberries. So what we want to do here is we want to add an item kiwi, a fruit kiwi, but because we want to append it, it's going to be added at the end of this particular list. So it will come after blueberries there. So how do we do that? So for you to append, you use a special function called a method. Methods are functions which only work with specific data structures. a function works with any data structure like print. A function like print, we have used it to print a list, we have used it to print a dictionary, we have used it to print a tuple, we have used it to print a set. So functions work with anything. But a method only works with a specific structure. You can't use a method for this particular data structure for anything else. So in this particular case, we want to append the item kiwi to the end of the list fruits. So how do you do that? With methods, you start out with the name of the data structure, which is a fruit, in this case the list, then followed by a dot, then the name of the method, which is called append, then in the parentheses, you put in the value of the item you want to add to the end of the list, which is kiwi. So if I run this, that's what I get. Then if I print out fruits, you see that kiwi has been added at the end. So every time you use append, the items are added at the end of the list. Is that clear? Then there is insert. Now when you're using insert, you need to specify an index before which this particular item is supposed to be added. So you need to know the location before which this particular item is supposed to be added. For example, I'll print out fruits. Now, the first position, I know that the first position is mango in this particular case. So what I want to do is I want to add an item before the first position, which means whatever I'm adding will become the first item. Is that clear? So you set the index, say this particular index. What you're adding is going to come before that particular index. So it's going to be inserted before that particular index. So in this particular case, my mango is the first item. So if I say I want to insert pineapple before index 0, it means that this pineapple will now become the first item in this particular list. So I start out, so how do I do that? I say fruits, then I put a dot, then I use a method called insert. Now what insert needs is the index. So I start out with the index before which I want to insert this particular item, then followed by the name of the item I want to insert. In this particular case, I want to insert pineapple, and if I run this, okay, then I print out fruits, you see that pineapple is now the first item because it was inserted before the first item. Is that clear? So the index, it's not that the item is added at that particular index. No, the item you're inserting, it's like you inserting someone in front of a line. People will not, if you're in a queue, people will not agree that you keep on adding people in front, behind you. So if you're really going to insert someone, you insert someone in front of you. So basically that's how this particular method works. So if you set a position, what you're inserting will be inserted in front of that particular position, or we can say before.
You can't insert in between?
No. You insert.
At the end, or?
No, in this particular case, you insert before that particular index. It's like you putting someone in. You remember how this guy when you're getting busy with before the banks came. So you insert someone in front of your line, not behind.
For example, between orange and grape.
Between orange and grape here. So between orange and grape, if you want to insert some item between orange and grape, you have to 1, 2, 3, 4, 5. Fifth item. So you have to use fourth. So the item will be inserted before the fourth. Yeah, before the fourth. What's it? Index number 4. Yeah. Now, you might want to add more than one item, because if you're doing append, you can only add one. If you're doing insert, you can only insert one. But if you want to add more than one item, for example, then there's another way of doing that. There's a method called berries. So I've printed out our list here. Then I create a new list called berries, and this new list called berries has got strawberries and these raspberries. I've not tested them before, but it's fine. Then I print out this list of berries. Now, if I want to add the list of berries to the other list of fruits, so basically I want to extend the list of fruits using these berries, then this extended list will be at the end. And how do I do that? So I use fruits dot extend, then berries, like that. You can run this, then I make a printout, and this is what you're going to see. So at the end here, you're going to see after kiwi, strawberries and raspberries have been added. So basically that's how we add items to a tuple. You can append, At the end of a list, you can insert before a particular index, or you can extend your list.
So, sir, if
Yes.
you're extending, it's more like appending.
But you're appending multiple items.
Yes.
Yes, kind of like append, but you're doing multiple items.
So you can't fix the wrong insert.
Sorry?
Where you get
Insert is something else. You insert, but you state a location, then you add one item before that particular location.
you can't do that. With
No, you can't. You can't. Okay. Any other question?
Are these methods that we are looking at, are they built-in functions?
Yes. That's why we are saying built-in data structures. So these things, you don't have to do anything. They are already there, out of the box. You don't have to make them. They are already there. Okay? That's why we chose these particular ones, because they're the most commonly used ones. They are built-in things. Okay. You can also do the same thing with something similar with a tuple. Now, the problem with a tuple does not have all these insert, append, extend things. So basically, with a tuple, you have to do things the kind of like the primitive way. You don't have the fanciness. So I print out a tuple here. Temporarily, this is the tuple I've printed out of prime numbers. I can extend the tuple of prime numbers. If I say, actually permanently, if I print out this bit here, I know this one, it's this one here. So for me to extend this tuple, I'll say plus this one, then the resulting operation of these two additions will be stored back in prime numbers then. So if I do that, then I do a print, now you will see that my prime numbers has got, it now includes these other bits in. So basically with a tuple, this is basically how you, this is basically an extension to a tuple. You can extend a tuple, okay? That's the only thing you can do. You can't insert things in the middle, but you can just extend it. Is that clear? Then we move on to a set. How do you add items to a set? There are a couple of ways you can do this. For example, if you want to, now the thing with a set, to start with, the thing with a set is you have to remember there is no position. If there is no position, it means that you can't do an insert, because an insert requires a position. Okay? So already you can figure out certain things you can't do. But it doesn't mean that we can't add stuff to a set. There is a method for doing that, which is called add. So if I print out the set static here, this is our set static. You can see. I didn't know ahead of time last week what the government was thinking, but you're aware the last 2 days we had visitors. The president of Rwanda came to visit us. So if I decide to say, fine, to this set of SADC, if you check, Mauritius, Zimbabwe, Eswatini, Namibia, Zambia, Mozambique, Tanzania, Congo DR, Botswana, Malawi, Madagascar, Seychelles, South Africa, Angola, Lesotho, there is no Rwanda in this particular set. But we can add it. And how do you do that? You proceed saying SADC.add, then you say Rwanda. There is no need for position. Now, in this particular case, when you do this, there is also no way of determining where Rwanda is going to be added. It is just going to be added, and the computer will figure out wherever to put it. Now, when I print out SADC, you see Rwanda is now there. It's not added at the end. It can be added at the end. It can be added at the beginning. It can just be added anywhere, because the thing of position doesn't exist with a set. It's basically a disordered data structure. You can add multiple items to a set if that's what you want. We just added one, but if you wanted to add more than one item, you can also do that, and you can use the update method. So this particular set, I print out my new SADC. Then I want to add more countries. For example, I want to add Burundi, I want to add Uganda, I want to add Kenya. So what I'm going to do, I'm going to say SADC.update, then I'll pass this list of items I want to add to the set. So there's a list of Burundi, Uganda, and Kenya, and if I run that, that's what I'm going to get. Then if I print out my updated SADC, now you see your Burundi is there. If you look around, you see Uganda has been added. Uganda is now faced, even though we've just added it. then somewhere there's Kenya there. Okay, but you can see Uganda and Kenya were next there, but Uganda is now first, Kenya is there, Burundi is there. So there's really no way of telling how things are going to be added, but they are simply just going to be added like that. Any questions on how you add items to a set? You can add a single item using add, or you can add multiple items using update.
Maybe going ahead, we have added. Is there a way of subtracting?
You can remove. Yes. There's a way. There's a way of There's a way of doing that. That's where we're going also.
Okay.
So you've added, then we'll show how certain things can be done. Then, for a dictionary, you can add key value pairs. You can add a new key value pair. You can add multiple key value pairs, and we're going to show how to do that. So you can add a new key value pair by different ways of doing this. So here, for example, I print out capital. Then, if you look at this particular countries which I have here, Kenya doesn't exist. But I can add Kenya, the key Kenya with its capital Nairobi, using this way. So I can first of all say capital, then square brackets, the key, which is Kenya, which should not exist at this particular thing when you're trying to add, because as we have seen before, if a key already exists, what you're doing is going to be modifying. Remember the Zambia Lusaka, then we said Zambian dollar. So if the key already exists, then if you give it a new value, what you're going to be doing is a modification. So if you're going to add, you have to make sure that the key does not exist in that particular dictionary. Is that clear? Okay, so in this particular case, if you look in our thing here, Zambia, Angola, Namibia, Botswana, Zimbabwe, South Africa, Pretoria, Mozambique, Malawi, Tanzania, Kenya doesn't exist. So what we are adding a new key value pair in this particular case. You can't just add a key, you have to add a key and an associated value. Exactly. So in this case, so we do that. If I run this, okay, and if I print capitals and I go at the end, I will find the key Kenya and the value Nairobi have been added. So in this particular case, your key value pairs are being added at the end. There's a fancy way of doing this, of course. There's a method, a dictionary method called set default. Now, set default can be used in a number of ways. Okay, you can use set default to add a new key value pair. You can use set default to add a new key value pair. For example, here, I want to add the key Egypt, and I want to connect it to the value Cairo, like this. So the key Egypt and the value Cairo. Egypt doesn't exist, so if we do that, okay, so it tells you, okay, Cairo, which is the value, and if I print out my updated dictionary and I go to the end, you see the key Egypt and Cairo have been added. So there's two ways you can do this. When you're adding one key, either you use the first method or you can use set default, but you might want to add multiple key value pairs if you have got more than one key value pair which you want to add. If you want to do that, then there's a method called update. Remember, I've seen update before, right? With a set, when we added Burundi, Uganda, and what is that? Kenya. But this method is not the same as the one for a set. But the thing is, dictionaries and sets are actually related. Because you can see how if you look at how a set works, how a set is created, it has got curly brackets. You see that? The difference here is that when it comes to a set, there are certain properties. In a set, an item can only exist once. In a dictionary, a key can only exist once. So basically, if you decide to say, okay, you're getting rid of the values, everything after the colon, you get rid of it. What you actually remain with is a set. If you've got a dictionary, then you get rid of the colon and the value. What you actually remain with is a set. That's why a key can only exist once, because a dictionary is a form of a set, but the values in a set they're being used, they're being mapped to other things. So those values in a set, basically those are the keys. So for a set, the keys do not have values. In a dictionary, the keys have associated values. Exactly. That's why the update thing is here. The update method is there because the set and the thing, basically it's the same item. And usually in this kind of object-oriented programming, you can end up having a method which works on both of them like that, as we're going to see. So in this particular case for capitals, I want to update these guys. So the set, I want to add Ethiopia with Addis Ababa, I want to add Nigeria with Lagos, like that. So basically, as you can see, I'm passing a dictionary to this method update. So it's going to add Ethiopia in Addis Ababa, Nigeria in Lagos. And if I do that, do a print, then do a print here, what we get is there. So we get Ethiopia here and Addis as the key, Nigeria key, and Lagos as the value. So basically, that's how you can add multiple key values to a dictionary. Any questions? Okay, then we move on to how do you remove items from a data structure. We'll go back to sets. In the case of a set, we know that, we go back to a list. In the case of a list, it's possible for you to remove an item based on its location, its position, or based on the value of the item. And we're going to see how to do this. So, you can use a function called delete. This is a new function, but this function it comes built in with Python. So with a delete function, as we are going to see, you need to give the delete function the name of the list you want to delete and the position of the item in that particular list. So in this particular case, the other thing is for a list might be very, very long. So this list, what I've created here is quite a small list, but this list can be very, very long. So it might not be possible for you by physically looking to see or to figure out correctly which position an item has. Now to help you, if you know the kind of item, the value of the item you're looking for, there is a method called index which works with lists. So with this method called index, as you can see in this particular case, I start out with fruits, then .index, then I give the name of the item I want to find, whose index I want to find, which is a grape. So what this scheme is going to do is, it is going to give me the location of this particular item, grape, in the list. Then that location will be stored in this particular variable position. So if I just do the following quickly, as you can see, if I just say fruits.index, then I say grape, and I run this, what I'm going to get is the index, the location of grape. 0, 1, 2, 3, 4. So this is how you retrieve the location of an item in a list. If you know the value of that particular item, you use a method, a special function called index. Now, once you get this value you have got here, you can store it in a variable, and that's what I'm doing here. I'm storing the value 4, which I'm going to get from this side. I'm storing it in the variable called position, like that. Then I print out position to confirm that the right thing has been stored. Then I can use this position now to delete the item grape from that particular list using the delete function. So I'll say delete, then I give it the name of the list, then inside the square brackets, I put the variable containing the position of that particular item I want to delete. So if I do that, like that, then if I print out an updated list, you will see that now grape doesn't exist. Is that clear? Is this clear?
Yes, now a quick question. Can I, instead of working with the variable position, can I just put the index myself?
Yes, you can put the index yourself if you know it.
Okay.
Yeah. Now, there's another way of doing this also. There's a method called pop. Now, we have used a function delete. Okay? So if it's a function, like in this case of delete, you can use delete to delete any data structure. Okay? But if you just want to restrict yourself to what can I use for what comes with the list, which I can use to remove things from the list, there is a method called pop. Now, pop can accept an index, and pop, you might not accept an index. If you don't give pop an index, then it's going to remove the last item in that particular list. If you don't give it a position, then it will just throw out the last item. If you give it a position, then it will throw out the item at that particular position. So this, yes?
On delete, is it possible to get the position and the value of that item medicine? You delete them directly without getting the position, and then you come to the item?
Yeah, for example, if you know the position, say mango is the second item, right? Therefore the index is 1, right? You can just put the...
No, what I mean, you don't know the position, but you know the item.
Yes. That's another way. We're going to come to that.
Oh.
You don't know the position, but you know the item. So you can use the value of the item to remove it. We're going to come to that. So with this particular item, pop, as you can see, the end is raspberries there. So I can say fruits.pop without giving it a position. When I do this, what is going to be removed is the last item in the list, which is raspberries there. So if you pop without giving index, the last item is removed. If I print out the updated list, you see that the last item is now strawberries. Okay? If on the other hand, there's cucumber somewhere here, I know there's cucumber, so I retrieve the position of cucumber using this line. Very handy, because you don't have to start counting. You don't have to start saying 1, 2, 3, 4, 5, 6. So cucumber is the 6th item. So if the 6th item, then the index is 5. I don't have to do that. You can just say, okay, I know the value of cucumber. Then through this line, fruits.index and cucumber, then whatever is going, the index is going to come out. You give it to this particular variable position. Then you print out position. There, you get your 5. Then now you can use this position to say fruits.pop, then you put in the variable position there, then it's going to remove the cucumber, and it's going to show you that I've removed cucumber from there. Then you can do your print, and you can see that cucumber has been removed from the list. So these two methods I've looked at, there were actually 3. The one with delete, this one with pop. These depend on the position of an item. However, it's possible for you to say, okay, fine, I know there's cucumber there. Then you just remove it right away using a method called remove. Now, remove does not require the position. It simply requires the value of the item you want to remove from the list. So with this bit here, I print out fruits. Now, fruits, there's lemon here. And so I want to remove lemon. So I'll say fruits.remove. Then I give it the value of the item I want to remove, which is lemon. Then I do that. I don't see anything. These other ones, they show you that something has been removed. But then if I check for lemon, which came after orange, it's no longer there. It has been removed. So basically, you can remove items by position, and also you can remove items by value. This is something you can do with a list, because a list is mutable. Okay? However, with a tuple, you cannot delete items from a tuple, because a tuple is immutable. You can't remove things from a tuple. If you try to get, you can get the position of an item in a tuple, for example, the value 17. What's the index of the value 17? Oh, sorry. Let me print out here. This prime number 17. I want to get its value, its position. So I do that. Then I print out the position. It's at position 8. If I try to delete this item, print, then I give the position with this bit here. If I try to do that, then I'll get an error, and I'm going to be told that tuple objects do not support item deletion. So basically, with a tuple, you can't remove things from a tuple. Once you add something from a tuple, you can't remove it. Okay. So with a tuple, you can't modify the value of an existing item. You also can't remove an existing item in a tuple, but you can add things to it. Are we clear? Is that clear? Okay. Same from a set. A set has got 3 ways. You can use remove, you can use discard, you can use pop, and let's see how we can do that.
Maybe a quick question.
Yes.
So assuming you write a script, most likely if we encountered a line like we just had, which gives an error, then the program will stop.
It will stop there.
Can't
It will stop there.
proceed.
No, it can't proceed. It will stop there until you fix that bit so that it can proceed. Okay. So here we print the set static. Now you can add things to a set, like we've seen, using add, using update, but you can also remove things from a set. For example, if you want to remove Kenya, you have Kenya here. You can use the remove method. Say static to remove Kenya. You can do that. Okay. Now there's a fancy way of checking if Kenya is still in a set. You can say Kenya, the value are not in static. So if this is true, then you get a true value. So this shows that Kenya has been removed from a set. So you can use these keywords not in static. You can also sorry, this is supposed to be discard here. Discard. Discard. You can use discard there. Then you can remove Zambia from static. So you can say static to discard like that. Okay. Then if you check if Zambia is still in static, no, it's not there. So you might be asking, what's the difference between remove and discard? Well, if you try to remove an item which does not exist in a set, then you get an error. But with discard, you never get an error. So if you try to remove something which doesn't exist, using the remove method, you get an error, but with discard, it's just quiet. If it doesn't find it, then you won't say anything. But with remove, it doesn't find it, then it will say something. Okay. Then of course, there is our pop. Remember, we're talking about a set, which means that the idea of index does not exist. But there is pop, which means that it's just going to throw out the last item it finds in this particular case. So if you print your set static, then if you look at the last item, which is Rwanda in this particular case, if I say static.pop, actually it doesn't even look at the last item, it just finds whatever it can find. Then it throws it out. So this is basically very dangerous to do because anything can be thrown out. It's just the computer, the way it feels, say, okay, fine, you, out. So it doesn't follow anything. So this way of doing things is not recommended at all. And if you print out your static, that's what you have. Any questions on how you remove items from sites?
How
Okay.
do you remove more than one item?
No. You can actually just remove one bit by bit. Yeah.
Or maybe, can you remove the whole thing?
You can clear the whole thing. You can remove everything. There's a method called clear for some of these things. For example, with lists, with sets, and and there's a method called clear you can use to empty everything, but not delete the other things out. So
Okay. We are at 7 minutes to 11. Maybe you can.
No, we started late. Remember, we started at 10.
Yes,
Yeah.
but the trouble is some people have classes or something.
Yeah, but let me have my 50 minutes because that's what the plan was.
Yes,
As you can
so-
see, I'm at the end there.
So yeah, try to run a bit.
So with a dictionary, you can use delete, you can use pop, you can also use pop item, and you're going to see how these things work. With delete, as we have seen, delete will require that you provide the name of the structure, and we use delete with lists, so we provided an index. But with a dictionary, you have to provide a key. Instead of an index, you have to provide a key if you're going to delete things with things. In this particular case, I want to remove Ethiopia and its value, so I'll say delete capitals, then in square brackets, the key and its value. In this particular case, Ethiopia, like that. If I do that, then I make a print, then that's what you're going to get. Then if you check down here, you see that Ethiopia is no longer here. You can also use pop. Now with pop, it's either you provide a key. In this particular case, you have to provide a key. So you say capital.pop Angola, in this particular case Angola and its value. The difference with pop here is that it will show you this value of popped. This value of popped is basically giving it back to you. You can do anything, whatever you want with it. You can save it in a variable and use it later on. Okay? And that's what you have there. Then, of course, now if you want to remove whatever the item is at the end of your dictionary, then you can use a method called pop item. So in this particular case, we print out our dictionary, then we can say, and if you look at your dictionary, what you have at the end there is Nigeria and Lagos. So if you say capitals the pop item, what you get is, what gets removed is this. You remove Nigeria and Lagos. So basically with pop item, you remove the last, yes.
So what if after it shows you the thing you want to remove, then you change your mind and you don't want to remove it anymore, can you reverse the process?
You have to put it back. We have seen how to add items to the thing. You can,
maybe there's a way right here.
no. Okay. Then you print out a bit there. Okay. So, so the last bit you're going to do is how do you delete all these structures you have created in this particular case. So basically, very easy. You simply use the delete function. With the delete function, you just give it the name of the structure. So in this particular case, for example, if we look at our fruits, that's what we have. So if I want to delete fruits, I just say delete, then I give it the name of the list I want to delete like that. And it's going to delete the whole thing. If I try to print out fruits, then it tell you, okay, the name fruits is not defined, meaning that it no longer exists. If you check your list of variables here, if it comes up, you will see that fruits no longer exist from there. Okay, meaning that it's been deleted. Similarly, you can delete a tuple as much as the tuple does not allow you to modify its values to delete items from the tuple itself. You can actually delete the tuple itself. Just say delete prime numbers, so which is the name of the tuple. Then if you try to print your tuple, it tells you prime number no longer exists. If you check here on the list of data structures you have created, you will see that prime numbers is no longer there. You can delete a set also. Here we have set Sadiq. You say delete Sadiq there. You try to print Sadiq, then it tells you Sadiq not defined because it's no longer there. If you check here, where there was all these things, these variables, varies that you see Comesa is there as a set, but the set Sadiq no longer exists because it's been deleted. Lastly but not least, of course, there is a dictionary. We created a dictionary capitals, which I've been working with, which is that bit there. You just give the name of the dictionary to the function, delete. You try to print out capitals and it tells you it doesn't exist. You check your workspace, your variable inspector here, because this keeps track of what variables you have created and which ones are already still existing. And you see that your capitals variable doesn't exist anymore. So basically, in a nutshell, this is what we wanted to make you aware of when it comes to these data structures. They are available for you to use out of the box in Python. Any questions? We have come to the end.
Maybe we can clap for now. So a few additions. We will have practical sessions of these things. Is it on Friday afternoons? Starting this Friday?
Yeah, we started last week with a bit setting up some second years and third years. This is basically tailored for second years and third years. So if you're second year and third year, you are very much invited to in physics, which might be physics from education, might be we have a lot of students from School of Mines who are just going to be with us for about one, but yeah, on Fridays in the computational physics lab, so that we teach you how to use computers in terms of just using the computer, the operating system, and also later on in terms of programming. Yes.
Okay, so that's that. Then these lectures are being stored on YouTube.
The recorded lectures, the recordings of the lectures are available on